the square of x plus x cubed plus 1 over x, everything squared. Do we need more time on this one?
No.
Okay, so y prime will be 2, the square of x plus x cubed plus 1 over x multiplied by 1 over 2 the square of x plus 3x squared minus 1 over x squared. And no one is asking you to do anything else. Is this okay? Yes, Brittany?
I had
Yes.
multiplied the 2 and the derivative of each of the numbers, so I had y prime equals 2 over 2 root x plus 6x squared minus 2 over
So
x
you
squared.
distributed all this. That's fine.
Okay.
Either way. You can. You can is probably, you can simplify it a little bit. Yeah, you can if you want to continue. Did I say there is no need to simplify in there?
Yes. No.
Yeah, so I'm fine if you simplify, I'm fine if you don't. Now, because the test, like every test is timed, although in class you will have extra time if you need to. You know me already. If you would like to go back and simplify it, leave it at the end. Don't waste your time, the precious time of the test. And then you can go back and simplify it if you'd like to. Okay, we're working on the second one. Any questions on the first? Yes, Ricky? Okay, so for this function, we used f raised to n prime. Yes, Mark, Harvey? Okay, so when we differentiate this, this is n times f to n minus 1 times f prime. This is the n, it goes in front. Then we subtract 1 from 2, which comes to be power 1. And then we differentiate. So this is this is this, and n is 2. So 2 times the function raised to 2 minus 1 times the inside or the function prime. We differentiate the square of x to get this. We differentiate x cubed to get this. We differentiate 1 over x to get this. Is that better?
Yes.
Very good. Other questions? Is this okay, everyone? We have this down? Yes? Yes? Okay. We're working on the second one. Reagan, can I copy it from you? I'm so sorry. My apologies. Say it again.
Do you want to have this, and then I can
Do you have another?
after that, but
No. I'll share. Braden is very kind. So sine 3x over cosine x minus sine x. Do we need more time or is this done? Do we need a moment? It's possible. I maybe not. Oh, here it is. I'm making enough coffee. I'm just lying to you today. Sorry. Got it. Yes. Vicky? Exactly. Yes. Yes. Of course.
Okay.
Are we ready or not yet? Are we ready on this? We need more time? Okay, so then f prime. We have to use the quotient rule. The denominator will be cosine x minus sine x, everything squared. We differentiate sine x. What do we get? Cosine 3x times 3 multiplied by cosine x minus sine x minus sine 3x times cosine prime. Of course, you know me, I ran out of room already. So this is negative sine x minus cosine x. No need to simplify. There is no need. I'm fine with this. You can distribute if you want. There is no need, though. You're not going to get far. So that's all I needed to see. Any questions on this problem? Anyone? Yes. You want? Go ahead.
So is it h times prime g minus g times prime h, or the other way around?
Well, if you want to use the method from the book, this will be the first over the second prime, and they put the prime first. They say 1 prime times 2 minus 2 prime times 1 divided by 2 squared. What I like to, what I think it's consistent, but it doesn't have to be. It's consistent for me, but it may not be for you. I write 1 prime 2 minus 1 times 2 prime, and I never forget what I'm doing. 1, 2, 1, 2. So it's either this or this. Both are acceptable. But if you reverse these two, you cannot get any credit. So if you put plus in front of this product and minus in front of this product, you will not get credit. So please be very careful. So if you write 2 prime times 1 minus 1 prime times 2, you will not get credit because that's not the quotient rule. Is it clear what I'm saying? Yes? Yes? Do we have other questions on this problem? Are we ready to move on? Anyone? Yes? Okay. So then we have y equals cosine to the third, e raised to tangent squared. Do we need a moment on this? Is that a yes? Do we need a moment? We need a moment or? Yes, so this is the same property that we just used. So this time is a cosine, so it's a function raised to the third power. It's the same rule. Mm-hmm. Yes. Mm-hmm. Correct. Yes, not yet. Good. Yes. To the correct. Yes. No, that's not times. That's the argument. Yes. Yes. You have to copy it. Yeah, that's part of cosine. Yes, that's the cosine function. That's what you have. You have cosine applied to e to tangent squared. That's your function. Now times cosine prime. You're not there yet. So let me show you here one more time. So this is your cosine, and this is your 3. So you have 3 cosine to the second power times cosine prime. Right, but then you have also an inner function. And then you have another inner function. So this is a little bit more involving because it's using the power rule. You have to use the power rule as well as the chain rule. Are we ready for this one? Yes? Okay, so then y prime equals 3 cosine squared of e raised to tangent squared. But now times cosine prime, which is negative sine of e raised to tangent squared. But now I have to differentiate this, which is e raised to tangent squared times, now I have to differentiate this, which is 2 tangent x times secant squared. It's a lot going on here. Let's go back and recap. Okay. So how many functions I see? I see the power 3. That's one function. I see cosine, which is the second function. Yes, Ricky, you want to say something? Okay. So power 3, and then cosine, and then e, and then tangent squared. I should say squared and then tangent. So first we differentiate cosine, which means 3 cosine squared of the argument. So don't get confused. This is inside cosine. You cannot separate them. Cosine right now is a function of e raised to tangent squared. So 3 cosine squared of the argument times cosine prime, which is negative e, negative sign applied to e to tangent squared. Now I differentiate this, which is e to u. E to u prime is e to u, and now times u prime. But u prime is a function squared, 2 tangent to 2 minus 1 times the inner function prime, which is secant squared. Now, remember when we are using the chain rule like this with the power rule, there is no additional subtraction. I have in the past students who write this and plus this and plus this and plus, no, there is no plus or minus. It's all a chain of factors. You can say, but there is a minus here. Don't forget what you want to ask. Yes, don't forget what you want to ask. 1 second. So the only thing that I can do is simplify tiny simplification with 3 and a 2 and a -1 and write -6 in front. But there is nothing else I can do. So cosine squared of e raised to tangent squared times sine e raised to tangent squared times e to tangent squared times tangent x secant squared. It's all multiplied. Multiplied, 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 multiplied. Yes, please. Who was first? Okay.
So how did you get the 2 tan x and the secant?
Very good question. When I differentiate tangent squared prime, this is a function prime to the nth power prime, which is n times f to n minus 1 times f prime, which means 2 times tangent to 2 minus 1 times the inner function prime, which is tangent prime, which is secant squared.
Oh, okay.
Is that clear?
Mm-hmm.
Everyone? Yes, Braden, please.
I understand how we got the beginning, the 3 cosine squared.
Yes.
I understand how we got like the sine and everything to the right of that.
Good.
I don't understand how we got the sine and everything to the right.
Okay, so this is n. This is the function to n minus 1. And this is the inner function prime. When I differentiate cosine, I get negative sign. So this piece is this piece. This is this. And this is this. Is that better?
Yeah, but why would it be negative sign times?
It's not times. So the function we are looking at is cosine. If I don't have this, every cosine, every function has to have an argument. The argument is not x. This is the argument of cosine. This is in place of x. I cannot separate cosine from its argument. I cannot separate cosine from x. In this case, I cannot separate cosine of this. This function is inside cosine. They cannot be separated. So I have n, which is 3, cosine to the second power, right? Because I subtract 1 from the power of the argument. See, I had to copy the argument here. So 3 cosine squared is not a product here. This is cosine applied to this times the inner function prime later on. So times cosine prime, which is negative sign of the same argument. So this is like saying cosine cubed of x. I will have 3 cosine squared times negative sine x. But I don't have x. So that's why I have negative sign of this.
Okay.
Yes, Ricky?
Is this being recorded?
I do. I am.
Okay.
Yes, absolutely.
So like,
Yes, I am recording this. Yes, yes, I made sure that I didn't forget, yes. Good, other questions? So this is the final answer, and you don't have to do anything else to it. Yes, please. Dylan?
So why isn't it, cosine times e to the power of tangent power 2 times x, and then to the power of 3 for f of u? Anyways, why is it kept as cosine to the power of 3 and then, you're multiplying by that function?
I'm not understanding the
Yeah.
question. Can you go back and rephrase?
Part of it, explain what you're asking. So I would write it as y equals cosine to the power of 3 times, e.
It's not times. It's
Or of.
cosine of.
Yeah.
Okay. So you want to write it, you want to write cosine of e to tangent squared to the third power.
Right.
Go ahead. That's fine.
So if I plug in f of u equals u to the power of 3, I could do that. And so.
No, you're not putting 3 on the inside function. You cannot do that. If that's what you're saying, I'm not sure. Forgive me if I misunderstood. You want to raise cosine and you want to raise this to the third? Maybe I misunderstood. Forgive me.
Yeah.
You cannot do that. So in other words, if I say cosine x to the third power, I do not mean cosine to the third of x to the third. No, I do not mean that. But yes, you can rewrite this expression as this expression and still get the same answer. That I accept. It's perfect. It's correct. And then you'll still have 3 cosine, the whole thing squared, times negative sine of this, times the e to tangent square prime, and so on and so forth. Nothing will change. But you can start the problem by replacing this by this. That is acceptable. If that's easier for you to see how to differentiate. That is fine. Was that the question?
Oh, everything about the answer is what you said.
Okay, we
I
can.
misunderstood.
I'm sorry?
Maybe I misunderstood.
Okay, we can sit down and talk about it. However, as I said, I have to go to the talk today. Okay, we'll move on to this. Okay, let's work on this for 1 minute. If you already work on it, don't let me waste the time. And just go ahead and work on it together. Let me know if you do it. Yes? Not today. No, I'm just reviewing today. Any questions? Do we need more time on this? Since I would like to be able to finish the whole test, I would like not to hold you back. So are we okay with this one, or?
Could go over it.
Yes, of course I will go over it, but I just want to know whether to wait for a minute or not. Okay, so this is 1, and this is 2. So I differentiate the first one as 1 over 2, the square root of 1 minus x squared times negative 2x. Do we accept this? Yes, Vanessa, go ahead. Every time we differentiate a square root, we always get 1 over 2, the square root of the function times the function prime. As a rule that I would definitely recommend we remember. So the first function prime is this, times the second one, arc cosine x, and plus, I should write minus, but that's okay. We'll see in a moment where the minus will come from, times the square root of 1 minus x squared multiplied by negative 1 over the square root of 1 minus x squared. Yes, we did this problem in class. It's in your notes. But we can do it again. as I promised, I select several of the problems that come from class. So when we differentiate the first function, we get 1 over 2 the square root times the inner function, which is negative 2x, times the second function. Is this okay with everyone?
Yes.
Okay, so I will simplify the 2 with a 2. And then plus, I copy the first function, and the derivative of r cosine is this. And as we said in class, if you remember, don't simplify. We could have simplified here and gotten negative 1. But the reason why I would not simplify is because both terms have the same denominator. So I will just copy the denominator as the square root of 1 minus x squared. And I will write the square root of 1. I'm sorry, I looked here instead of here. Sorry. My apologies. So I will have negative x r cosine, and you can put the x in front. And in class, I also moved negative 1 in front of the fraction line. So this is negative x arc cosine x minus the square root of 1 minus x squared. So we have negative x arc cosine from here, and we have minus the square root of 1 minus x squared from here. And the only thing that I would recommend is just put the minus in front as x arc cosine x plus the square root of 1 minus x squared over the square root of 1 minus x squared. That's it. Yes, please, Jared. Go ahead.
To like cancel the c's out.
Oh, we simplify, yes. That part we have to simplify. Yes. Because then you will not even have the same denominator. Yeah, so you have to do that. Any questions? Yes?
Can we write it as x arc cosine x over the square root of 1 minus x squared minus 1?
Yes.
Okay. I just wanted to make sure that.
Yeah, normally we would like to add the fractions. So that's why I left the same denominator. I didn't simplify, but both are acceptable. Any questions on this problem? Yes, please, Brayden.
For where you have the plus square root 1 minus x squared, is that times negative 1 over 1 minus?
Yes, because otherwise I would have had an operation symbol here. Yes. So it's the first function prime times the second one plus the first function times the second one prime. Yes, of course. It has to be. It's a sum of two products. Okay, y equals hyperbolic sine squared of hyperbolic cosine. So are we working on this for a minute or not? Same thing, chain rule combined with the power rule. Chain rule combined with the power rule. Can anyone dictate? Anyone would like to?
Y prime equals 2 sine h
Hyperbolic sine
times
of hyperbolic cosine. Remember, you cannot separate these two. It's sine, hyperbolic sine of hyperbolic cosine. Good? Times
No, cosine.
cosine, hyperbolic cosine of hyperbolic cosine times, yes, hyperbolic sine. Perfect. So 2 times sine times the inner function prime times the innermost function prime. They're all products. Now this is sine of. This is cosine of. Product, 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 product. This is one piece. It cannot be separated. This is another piece. It cannot be separated. Okay, so problem 2 will take us some time. We did this problem in class. We can come back and do it again, but let's finish the rest and then we can come back to that. We did that problem in class. It just will take a little bit longer. Oh, you know what? Let's not skip. We'll do what we can. Since the test is on Tuesday, that's fine. So let's work on this. So we have S or F of t equals t to the third minus 6t squared plus 9t. So how will we time? Okay, another hour, 15 minutes. We should be able to finish. Okay, So here's the first question. A particle moves according to this law, where t is measured in seconds. T in seconds. This is very important to take notes or remind myself that the measurement unit for time is seconds and for s is in meters. Because if I forget to state the measurement unit, then I will not get full credit. Okay. Find the velocity at time t. How do we find the velocity at time t?
On V.
V of t, excellent, which is f prime of t. Awesome. So this is 3t squared minus 12t plus 9. Do we all agree with this? Bless you. So this is the velocity function at time t. Part B. What is the velocity after 2 seconds and 4 seconds?
Plug in 2 and 4.
V of 2 and V of 4. If you have the answers, if you calculated them, just give them to me. Negative
Negative 3.
30. Negative 33.
No, just negative 3.
That's not enough.
Meters per second. Meters.
Good. And the other one?
9 meters per second.
Do we agree with negative 33 and 9?
I think it's
Just negative 3. Did not.
Oh, negative 3. I'm sorry. Sorry about that. Should I check my hearing? Okay, so negative 3 meters per second and 9 meters per second. Do we have 2 or 3 answers like this one, or do we understand how we get this, right? We just plug it in. Everyone is okay? Yes, Vanessa?
We plug it in that formula, but then we just.
V of 2,
Okay.
V of 4. Did we get negative 3 and 9? Excellent. Okay, part C. When is the particle at rest?
V of 0.
Very good. When the velocity is 0, then the particle will be at rest, which is 3t squared minus 12t plus 9 equals 0. You know me a little bit, at least. What do you think I'm going to do now?
Make a table.
Yeah, plug the 3.
Divide both sides by 3, of course. So t squared minus 4t plus 3 equals 0. And if it's factorable, I will factor it quickly. If it's not, if it takes longer, I will use the quadratic formula. Is it factorable? Okay, into. So t equals 1. 1 is seconds, and t equals 3 seconds. So the particle is at rest when t is 1 and when t is 3 seconds. When is the particle moving in the positive direction? Now I have to use a table. So here's our table. T, V of t, 0, 1, 3, infinity, whatever, unless we are given something else. I know this is 0 and this is 3. I need to find the sign of the derivative. Here's the derivative, 3t squared minus 12t plus 9. Let's plug in a number on this side, like 0. What is the sign we get? If you plug in 2, I agree. And if we plug in 10, positive. So we consider the positive velocity that is moving in the positive direction. We consider the negative velocity. You can say left to right, or you can say up and down. It doesn't matter. So this is moving in the positive, and this is moving as a positive, and this is moving in a negative. So I will say for t in the interval 0, 1, union 3 to infinity, positive direction. And between 1 and 3, negative direction. Questions? Okay, now they're giving us the first 5 seconds. So I really care about 5 here. It doesn't matter. It's not a mistake. You can keep infinity and then come back and think about 5. It doesn't matter. So question E. They want the total distance. And this will be S1 minus S0 in absolute value plus S3 minus S1 in absolute value plus S5 minus S3 in absolute value. I will put the function in the graphing calculator. In y equals so the function, the distance function is t cubed minus 60 squared and then plus 9t. And go to second and table. And I want 0. Of course, it will be 0. I want 1. I want 3. And I want 5. So then I will write 4 minus 0 plus 0 minus 4 plus 20 minus 0. Like this. Four minus 0, 0 minus 4, plus 20 minus 0. So obviously this is 4 plus 20, which is 28. Measurement unit. Yes, please, Vanessa.
Let's say S of 11.
No, I'm so sorry. It's S of 1, right? So we only have 0, 1, 3, and 5.
Yeah.
S of 1 minus S of 0 plus S of 3 minus S of 1 plus S of 5 minus S of 3. My apologies. 28. Measurement unit, please. Excellent. Find acceleration at time t and after 4 seconds. Acceleration. Very good. So v prime of t or f double prime of t is 6t minus 12. Is this clear? Then we want to find the acceleration. So let's call it this a of t. So we want the a of 4 seconds. So 24 minus 12 is 12. Measurement unit.
Meters over second squared.
Very good. It's my my habit to write SEC, but you don't have to. This is meters per second squared is fine. It's just a habit. My apologies. When is the particle speeding up and when it is slowing down? Yes, please. Jared?
Can you go over emails again?
E?
Part E.
Which part?
How you got the,
From the calculator. I copied 400420.
oh, so it's from the value plugged in.
Yeah. I determine S of 1, S of 0, 4 and 0. I determine S of 3, S of 1, 0 and 4. And I determine S of 5 and S of 3, and I put them here. Is that okay? Everyone? Is this okay? Okay, so final question is asking us to find, yes. And of course, we're going to stick with 0, 1, 3, and 5. So V of t, A of t, and conclusion. And we also have to insert in there t equals 2, because the velocity is 0 at t equals 2. So I'm going to copy from the table from the velocity. I'm going to copy the zeros. I'm going to copy plus and minus and then plus. And then I'm going to determine the sign of the acceleration. So can anyone tell us what is the sign of the acceleration between 0 and 2?
Negative.
Yes, very good. And between 2 and 5? Very good. So then we have several situations. Situation 1, situation 2, situation 3, and 4. Bless you. So can anyone tell us what happens between 0 and 1?
Slowing down.
Slowing down, I'm just going to show a down arrow. What will happen between 1 and 2? Yes, I'm going to show it as a up arrow. But please write slowing down and speeding up. Between 2 and 3. Can anyone explain why that is? When the acceleration and the velocity work against each other, one is going this way and the other one is this way, then the particle will always slow down. When they help one another, regardless in which direction, they are going in the negative direction, it doesn't matter, but they're helping each other, so the particle is speeding up. Here, again, they are working against each other. One is negative and one is positive, so that's why it's slowing down. And what happens here? Speeding up because they are working together. Remember that silly example that I gave you? Here's an accurate example. When you travel, sometimes in the winter, from here to the west coast, on the same distance, 2,300 miles, will take you potentially 6.5 hours because of the west winds. When you come back, you're going to be here like under 5 hours versus 6.5 hours, and it's the same distance. So why is that? You're speeding up because the speed of the plane and the tailwind are working together. But you're going towards the west coast, and the speed of the current is against the airplane, right? The speed, so they're slowing down. If the airplane can do, I don't know, 400 miles an hour, and there's a 100 mile an hour headwind, you're only doing 300. That's why it takes longer. And actually, it happened to be one December, we had to stop and refuel because it was taking so long, and they ran out of fuel. So we didn't make it to the West Coast because of the headwind. Yes, Braden? Without a stop.
So the table is saying.
The table is saying that the velocity and the acceleration are working against each other, so the particle is slowing down.
For
Between 0 and 1 second.
okay.
Between 1 second and 2 seconds, it's speeding up. Between 2 and 3, slowing down. Between 3 and 5 is speeding up.
2 and 3 is speeding up.
2 and 3 is slowing down. 1 is negative, 1 is positive. Okay, yes, please.
Can we go back up to F, part F?
Yes? It's just 60 minus 12. We are differentiating again to get the acceleration. The acceleration is the velocity, the derivative of velocity, or the second derivative of the function, of the distance function. Okay? 6 times 4 minus 12 is 12. Is that okay? Good. Anyone else? Other questions? Yes, Braden?
Back to the table.
Yes.
Why is the 2 for the t again? Why do we put the 2 there?
Because I have to study the sign. So the acceleration is 0 when t is 2.
Okay.
If I don't have the 0 of a function, I can't determine whether it's positive or negative. I have to find the x-intercepts first. And that there is only one x-intercept. It's a linear function.
How did we know it was 2? Because I thought 1 and 3 was
6t minus 12 equals 0. 6t equals 12. T equals 2. I have to find the 0 of this function.
okay.
And the 0 of that function is 2. You understand that if I don't have the 0, I cannot establish the signs. I have to get the x-intercept first in order to establish the signs. If I don't have the x-intercept, then I will not know where the sign changes. Is that okay?
Yes.
Perfect. Moving on. we're given f of x, which is x squared minus 1 squared times e to the x. Find f prime, simplify the final form by factoring. Find the equation of the tangent line to the graph of f of x at the point 1 comma 0. How do we start this one?
Product through power rule.
So we have to find the derivative, okay? Ready? Can anyone get us started for the derivative? Yes. Times. Times 2x. Times. Very good. Plus.
X squared minus 1 squared
Yes.
dx.
Times e to the x. Very good. And we see common factors here. Can anyone give us the common factors? Yes, so definitely an x squared minus 1 and an e to the x. And let's see what is left. What is left from the first term? This is out. This is out. 4x. Very good. Plus. What else is left?
X squared minus 1.
X squared minus 1. Do we all agree with this? Is that okay? Good. So the only thing I would do, I would just rearrange it. And just write f prime of x equals x squared minus 1 e to the x squared plus 4x minus 1. And this was 5, 6, 7. Very good. Okay, so we have the equation of the line given a point, but I'm missing the slope. The question is, how do I determine the slope? Plug in 1 indeed. So all I have to do is find f prime of 1. Can anyone give us x squared minus 1 when x is 1?
0.
And e2 doesn't matter. And all this doesn't matter. So the answer is 0. So we have y equals 0 times x minus 1. So then y equals 0 is the equation of the tangent line to the graph of the given function when x is 1. Yes, please.
Why do we have to find f prime of 1?
Because if this is the function and this is the point 1 comma 0, in order to determine the slope of this line, the slope of this line is f prime of 1.
Okay.
So that's the reason why we determined the derivative, and we plugged in the x of the point to determine the slope of the line at that point, the slope of the tangent line at that point. Is that okay? Everyone? Very good. Next one. We have a limit as x approaches 0 from either side.
Ricky has a question.
Oh, I'm sorry, Ricky.
So.
So 1 minus 1 is 0, e to 1 is 1, and this is negative 1. So 0 times 1 times negative 1. Better?
So.
Yeah. Is 1. So this one is 0. 1 minus 1. Yes. E to 0 is 1. Is that okay, everyone? Other questions? Okay, so then sine 5x divided by 7x squared. I do not recommend L'Hopital's rule on this, even if when you plug in 0 over 0, you get what?
0 to 0.
Yes, I don't recommend it. However, I do recommend a very simple algebraic manipulation, like limit as x approaches 0, sine 3x, 1 over 7 in front, over x, times 5 sine 5x over x. So I split the fraction into 1 over 7 outside. I don't care for 1 over 7, can wait. I can even put it in front of the limit operator if I wanted to. And then sine 3x over x, and then sine 5x over x. So as you see, I didn't change anything. It's still 7 times x, which is 7x squared. It's still sine 3x, and it's still sine 5x. However, remember, this function requires that sine 3x is also approaching 0. 3x also approaches 0, and 5x also approaches 0. And it does. They all do, right? If x approaches 0, then 3x and 5x will approach 0. So this is okay. So this is our box, and this is the triangle, which is the same thing. However, I have to have the same thing in the denominator, so this is what I need to do. Multiply top and bottom by 3, which is allowed. Multiply top and bottom by 5, which is allowed because it's 1. If I multiply the top by 3 and the bottom by 3, I multiply by 1, which makes no change whatsoever. But now I know that this piece, and I also know that this piece, both will approach what? Assuming that this approaches 0 and this approaches 0. Thank you. 1. So then what is left? A 3 at the top, a 5 at the top, and a 7 at the bottom. And the answer is 15 over 7. Yes, Braden?
Could you have done that like for any problem?
Yes. As long as, let me refresh everyone's memory. As long as I have the limit of a box that approaches 0 from sine of a box over the box. As long as all these three things are identical. If they're not identical, or if there is a different number here but 0, the answer will not be 1. So this, and the sign, all of them have to be what you see here. And the three boxes have to be identical. And then the answer will be 1. Yes, Ricky?
What if it was cosine?
No. It's a different story with cosine. So this is something we studied a long time ago, and we graphed it because we could not prove with L'Hopital's rule. But then later on, a few weeks ago, we did prove it with L'Hopital's rule. But no, not with cosine. It works only with sine, and it can also be reversed. So the same thing is for limit as the box approaches 0 from the box over sine of the box equals 1. Yes. Both are the same, but not with cosine.
Can you go back to the previous page?
Yes. Any questions on this? Any questions? I'm hoping that you worked on all these problems before coming to class so you don't start from scratch and have to relearn all this for Tuesday. I hope, that's my hope. So f of y equals y minus 1 to the 4th, everything over y plus 2 to the 5th. So then f prime of y.
4 y minus 1.
Say it again. Yes, we have to use the quotient rule. That's fine. Also, remember, this problem will ask you to complete